Our group created a 3D virtual reality game, Crazy Maze. So navigation and memory are essential parts of moving efficiently through different environments. So for example, when you're lost in a forest or you have somehow ended up in a maze, you're most likely relying a lot on your vision. So landmarks such as a flower or an odd-looking rock can help you orient yourself and navigate these environments. So these visual cues serve as reference points, helping you to remember where you've been and guiding you toward your destination. But what happens when you no longer can rely on your vision? So instead of visual landmarks, vibrations can serve as a cue, simulating the way touch is used to perceive surroundings in low vision scenarios. So we therefore wanted to compare the visual modality and the haptic modality. And to do this, we designed two different mazes with landmarks. So one maze with visual feedback and the other one with haptic feedback in form of vibrations. So the visual feedback mimicked the typical reliance on sight for navigation, while the haptic feedback simulate the use of touch to perceive and navigate surroundings, particularly in low vision scenarios. So we set up the game using Unity and the MetaQuest VR headset with belonging controllers. So what you can see here is a sketch of our game. So the idea is that the player will have to find their way out of the maze with the help of either visual or haptic landmarks. So when the player steps on a red landmark, they are given either visual feedback or haptic feedback in the form of a vibration pattern, which is felt through the controllers. So here is a demonstration of how the game works. We first let Alexander try the visual maze. He stumbles upon his first landmark, a red square on the ground. As he steps on it, a visual cue in the form of a pink square pops up in front of him. And as soon as he leaves the square, it disappears. He navigates the maze using the joystick on the controller, allowing him to move around in any direction. Alexander spots a landmark again, and this time it shows a green color. And by relying on his memory, Alexander realizes that this is a new landmark. It signals that he has reached a location he hasn't visited before. He then knows that he might be on the right track. In addition to using the joystick, he can explore his surrounding in the maze by physically turning his head to look around. He then continues to explore the maze until he finds his way out. And there he is, free at last. So this is an overview of the maze and the different colors of the landmarks. To be able to compare visual and haptic feedback, Alexander tries the haptic maze next. So instead of visual cues, we now have different vibration patterns that are felt in the controllers. Here, he has found his first landmark and felt the vibration in his hands. Like the visual maze, he can explore the maze in the same way by moving his joystick and his head. Here, he finds another landmark. And it's another vibration pattern. Alexander will keep exploring until he finds his way out of this maze as well. And because he's trying both modalities, the maze layout and the placement of the landmarks are different for each modality. So the game was developed in Unity game engine, and we used an iterative design approach as we continuously tested the game while we developed it. So for evaluation, we first held a pilot study where we got feedback on the game design and also the vibration distinctions. We also followed a within subject design where we recruited 10 participants to try out our game. So we chose this design as we had a rather small sample group, and by having the first half starting with testing with one modality first and the other half starting with the other modality first, reduce the risk of having the order affecting the results. Our evaluation mostly focused on quantitative data, but we also had supporting qualitative data. For the quantitative data, we measured the time it took for the participants to complete the maze and the number of correctly placed landmarks, where each participant had to place out where they thought that different landmarks were located in the maze, as a way to measure how well they remembered the landmarks. So to support our quantitative data, we held short interviews with the participants after the session, where they got to answer 4 questions about their experience with visual and haptic feedback and the effect on their memory. The time it took to complete the maze with the visual landmark and the haptic landmarks were measured during the test procedure and analyzed by calculating and comparing the mean and the median and the standard deviation of the time it took to complete the mazes for all participants. So to the left here, we can see that it took longer for the participants to finish the maze with the visual landmarks. The mean was 150 seconds, and then compared to the maze with the haptic landmarks, the mean was 115 seconds. So to the right here, we have the number of correctly placed landmarks, where the mean was 3 correct placements for the visual maze, which was more compared to the haptic maze, where the mean was 2.2. So a qualitative analysis was also made, where 4 questions to the right were asked. From the answers to these questions, the results in the 4 diagrams to the left here could be drawn. So overall, the results show that the visual landmarks scored higher compared to the haptic landmark when it came to how much they helped to complete the maze, and also felt most natural and was the easiest to remember. So our results revealed some fascinating insights. When we compared the time the participants took to complete the mazes, the maze with the haptic landmarks was completed much faster. And this suggested that the haptic vibrations may enhance navigation efficiency. However, when we looked at the participants' ability to recall where they encountered the landmarks, the visual landmarks actually performed better than the haptic ones. So this aligns with the participants' feedback, where they rated that visual landmarks are more natural, memorable, and helpful. So these findings also reflect that previous research by Huyat Madani and Reed, showing that people are generally better at remembering sequences of visual cues than haptic ones. The disconnection between faster navigation time with haptic cues and better memorability with visual cues may be caused by several impacting factors. So for now, it seems reasonable to place more weight on the participants' reported experience. This is because of the impacting factors. One of the biggest factors seemed to be the time it took to finish the mazes. This was likely influenced by the fact that the 2 mazes had different layouts. So we designed them this way to prevent participants from learning the layout during the first attempt and then using the knowledge in the second maze. But by making the layouts different, it looks like we unintentionally made the mazes different difficulty levels. So despite being the same size and having equal number of crossroads, the maze with visual landmarks appeared to be a little more challenging. So to conclude, our study provided us valuable insights in how visual and haptic landmarks affect navigation and memory. So haptic feedback led to faster navigation time, while visual landmarks were more useful for memory recall, where participants found them more natural and easier to remember. And these findings reveal both strengths and challenges of the two modalities. It also provided potential areas for improvement in accessible navigation in VR, and especially for individuals with low vision. So future work could focus on refining haptic cues for better differentiation and also make sure that the maze difficulty is consistent.